At this stage of development, I currently have a fully functioning 2D fluid simulation and a partially complete 3D fluid simulation. The 2D simulation which is currently being depicted is achieved through solving the incompressible Navier-Stokes equation. At each time step of the simulation, a 2D grid is calculated from solving Navier-Stokes. Within this demo of the 2D simulation, I am adding density along the entire width of the fluid at the bottom. I am then adding to the velocity within the same location. To render these results, the values at each point on the grid can be mapped to RGB color values and applied per pixel to geometry within the game world. To create 3D fluids, an adapted solver of the original 2D solution can be used. Here is the result of the 3D simulation so far. Currently, the visual quality of the 3D simulation is notably less impressive and suitable when compared to the 2D simulation. The rendering technique for the 3D based simulation is complex when in comparison. Like the 2D based simulation, a 3D grid filled with numerical data describing the fluid is outputted from the simulation. To be able to draw this data, volume rendering is required. The volume renderer implemented within this project uses the volume ray casting method and is entirely performed on the GPU via a pixel shader. The next aim of this project is to take the simulation and perform it entirely on the GPU. As can be seen within the profiler, GPGPU is not entirely necessary for the 2D based simulation. This is a profile of 100 by 100 fluid field constantly being updated, which sits at around a comfortable 40 frames a second. However, the 3D based simulation on the CPU is significantly worse, sitting at around 6 FPS on a 50 by 50 by 50 cube.